This video is not for commercial purposes. It is intended only for Singidunum University students as a course material. My name is Nebojša Bačanin-Đakula, and in today's video I'm going to make a brief introduction to Oracle SQL Developer Data Modeler software. As you know, Oracle SQL Developer Data Modeler is used for creating of logical data models like entity relationship diagrams. First, we have to download Oracle SQL Developer. I'll just type Oracle SQL Developer Data Modeler download in the search engine, and I'm going to click on the second link. I agree. All we have to do is to click on this button download and to choose the right version. In this case, I'm going to choose the version for Windows 64-bit operating system. Before you do your download, you need to check which version of Windows you have. Just press the Windows button and the pause button on your keyboard, and you'll see the version of Windows operating system. And as you can see, in my case, I have 64-bit operating system with Intel Core i7 processor 4th generation. Okay, the second thing you need to consider is, do you have JDK, Java Development Kit, installed on your system or not? If you have, you will download this version that does not include Java Development Kit. In the opposite case, if you don't have Java Development Kit, you will download this version. Okay, I have already downloaded the software. So here I have Data Modeler. When we first download Data Modeler, we download it as archive file, and we need to extract this file. I've already done it, so I won't do it again. So when you extract, you have the folder called Data Modeler. Data Modeler is a portable application. That means you don't have to install it. You can just run it. I'm going to double click on it, and in many cases we need to browse and to show this software where is Java Development Kit installation. This is because I use this version without Java Development Kit, because I have already installed it on my computer. So I go to Drive C, to Program Files, I go to folder Java, and here I have JDK 1.8, that's my folder, and I just click OK button. And after that, Oracle SQL Developer Data Modeler will start. Okay, so I have my Oracle SQL Developer Data Modeler start window. In this example, I'm going to show you very simple implementation. We are going to create a very simple logical model and relationship diagram, and after that we will engineer this model to the physical or relational model, and finally we will use this model to generate DDL, data definition language statements, so we can create the actual implementation of this model. So first thing we want to do is to right click here on the logical model and to click on show. And now we have a pane where we can create our logical model. So as I mentioned before, I will create a very simple logical model. First, we need to create entities. You see this button here, it says new entity, just click on it and again click on this pane. First entity will be called student. So when created entities, we don't use plural, we use only singular. So this entity is student, we just click OK. We can drag and drop entities wherever we want. After we've created entity, we want to create attributes. I just right click on this entity and go to properties, and then I choose attributes. First attribute will be ID. That will be unique identifier for this entity, and then I can choose the data type. Data type can be domain. If I already have predefined data types, and in this case I don't have it, they can be structured and logical. I'm going to click on logical and choose from this drop-down list numeric. So this ID is numeric data type, precision is 9 and scale is 0 because it will be unique identifier and later the primary key. I click apply and then I can add the second entity. It's simple first name, for example. It's again logical and data type is varchar. I click apply. Then, for example, I'm going to create a last name. It will be also logical, varchar. And I'm going to add another entity called contact or something like that. It will be logical and varchar. So in this attribute, we can put information like student's phone number, email address, etc. Okay, so now we've created our first entity. Now we want to designate this ID attribute as the primary key that will be used later in the relational model. For example, we can choose this select tool and double click on the entity, and the properties window will open. We go to unique identifiers, we go to add, after that we go to properties, and here is a little bit of catchy thing because Oracle SQL Developer is buggy. So first we have to go here to choose attributes and relationships and to move this ID because ID will be unique identifier, and after that we go to general and we name this unique identifier. We'll say student underscore PK like primary key because this will be primary key in the relational model, and here for state we choose primary key. Apply, OK, apply, OK. And now notice that here we have a hashtag symbol besides ID. That means that ID is unique identifier. I'm going just to check it one more time. And here when we go to attributes, we have here primary unique ID. OK, we click to apply and OK. So that's our first entity. Second entity will be course. Again, I go to new entity, say course, OK, apply, OK. This is our second entity. I will stretch it a little bit. And now we need to define attributes for this course. Course will be just a high-level description of the course. Just a high-level description. So first attribute will be ID. This will be primary UID and primary key, as in the case of student. And for example, the second entity, and I first need to define data type. It will be also numeric, precision 9 and scale 0, for example. Okay, and then we add a second entity called, for example, name, course name. It will be a logical varchar data type. Go to apply, and the third entity will be, for example, description. It also will be a logical entity with varchar to data type and size. I don't know, it doesn't matter, for example 30. Okay, and I didn't put the size for this, it also be 30. Okay, so that's our second entity, but I forgot to put size for first, last name and contact, so I'll do it now. Okay, first name 30 characters, last name 30 characters, and contact, okay, for example 20 characters. That's okay. So that's our second entity. Now we are going to create an entity called course section. This entity will be actually courses that students will take. So one student may take many course sections, and one course section may be taken by many students. So again, we go to the new entity button here, go to just course section. Okay, apply. Now we go to the attributes, and for this course section we won't have an ID attribute because it will be inherited in identifying a relationship from the course. But in order to designate uniquely, let me say, each instance of the course section, we'll need the begin date, end date, and location. So first attribute will be begin date. That's the date when the course section starts. Okay, it doesn't matter, it will be date, time, data type. Second attribute will be end date. Okay, it will be again date, time, data type. And finally we will have attribute called location. It will be logical, of course, and varchar. So that's the location of the course. For, I don't know, we'll put 50 characters for the size. So first, data type begin date and location will be used to uniquely identify each instance of the course section. We finally go to the apply. And now we have set up 3 entities here. And one more thing before we start creating relationships, we need to set this ID as the primary key or unique identifier. We go to unique identifiers, add, properties, attributes and relations, ID we'll put here. Okay, click on the apply. We go to the general, and primary key will be named course underscore PK or primary key. And here we put primary key. Okay, good. And now we have a basic model. Now we want to do is to set up relationships. So one course may have many sections. So the relationship between course and course section will be one-to-many, but it will be identifying relationships. What does it mean? It means that the primary key from the course will be used as a part of the primary key of the course section. So here on this bar we have different relationship types: M-to-N, one-to-N relation, one-to-N identifying relation, and one-to-one. We need this one-to-one, one-to-N identifying relation, we just hit here. First we click on the source entity, this is course, and after that we click on the destination entity, which is course section. Now we only have to define the name for this relation. This relation will be course underscore F key, that means foreign key. Why did I name this relation in this way? Because in the relational model, in this course section entity, which will become table, we'll have course foreign key attribute, which will act as the foreign key for this relationship. Okay, that's how we establish one-to-many relationship. Okay, we click OK, apply and OK. Okay, so on this side, this relationship is optional, and on this side it is mandatory. Why? Because the course section cannot exist without the course. So in the descriptive language we say like this: one course may contain many course sections, and if we read this relation in the opposite direction, we say one course section must be included in the course. Okay, so that's our first relationship. A second relationship is between student and course section. We said that one student may take many course sections, and also one course section may be taken by many students. So the entity between course section and students is many-to-many. So here on this bar we have end-to-end relation. Just click on the student and on the course section, and we'll say, I don't know, student course section relation. Okay, and we have now many-to-many relation. However, this is not correct. Why? Because many-to-many relation is established by creating intersection entity, and then between each entity that anticipates in the many-to-many relation, we create one-to-many relation between this entity and the intersection entity. So what do we have to do? Okay, so first I will delete this relation, and then I say that in this course section entity, for example, begin date and location will be primary key, more precisely part of the primary key, because in this point primary key is just ID, which is inherited from the course, but I want begin and location to be as well parts of the primary key. So I just double click here, I go to unique identifiers. Okay, this is good. Attributes relation. Okay, good. I have everything set up. Okay. So now we create intersection entity. Intersection entities is usually named by main entities. So in this case we have student and course section entities, so we will create a new entity and call it student underscore course section. So that will be our intersection entity, and with this point in time I can remember of only one attribute for this entity. It will be grade. For example, attributes add grade, and we'll choose logical data type, and we'll choose small integer because it's small. Okay, so it's intersection. This is intersection entity. And now when we created our intersection entity, we need to establish two one-to-many relations between student and student course section, and between course section and student course section. So here we choose new one-to-n relation, but again it will be identifying relation, because primary key for this entity will be inherited from the student and from the course section. So here I just click on the student and the course section, and I'll call this student f key for key, like in this example, because this student ID, or ID in this case on the entity relationship diagram, will be a foreign key and a part of the primary key. Okay, I click apply. Okay, and now we create a second identifying relationship between course section. So we just click on the course section, and between the student course section, and this relationship will be named course underscore section f key, foreign key. So good. And now I need to check what the primary key or unique identifier from this student course section is. I just double click on it. I go to unique identifiers, edit, and I see that I have these two relationships as the primary key. Okay, that's good. So at this point we have created a very simple logical model used just for demo purposes of Oracle SQL Developer Data Modeler. And so I'll do one more thing. I'll go to this course section and go to this attribute begin date, okay, and choose this primary unique identifier for the begin date. And then I go to the location and choose this to be primary unique identifier. Okay, okay. So now we have our basic model. That's a logical model, and now from this point we can engineer this model to the relational or physical model. We just need to press this button, engineer to relational model, and click here, engineer. And now we have our relational model. So as you know, in the relational model, entities become tables, attributes become fields, unique identifiers become primary keys, and also in this model, you remember here in the course section entity, we did not have this course ID as the primary key. We didn't have it. But here we have it, because in the relational model we have all the attributes. So let's examine here, for example. Here we have a student ID, that's this field. It's both primary key, that means this P, and F foreign key. And also we have course section course ID, that's this field, which is inherent from this entity up to here, and this is also primary key and the foreign key. And then we have begin date and location. So that is our relational model. And finally, now we can generate DDL data definition language statements from this relational model. I can stretch a little bit here, okay. So we can create now DDL statements. We couldn't create DDL statements from the logical model we can create DDL statements only from the physical or relational model. We can go here to View and choose DDL file editor. We choose the version of the database. I choose Oracle 12c. C means cloud. Okay, but first we have to save this, our model, something like that. Okay, and close. And then I want to save the whole this design, both logical and physical. So again, I go to desktop and I'll save, for example, our model. Okay, this model is saved. So if I go up here, this is for DDL. I have two files. We have our model DMD, that's a basic file that's used for the whole model, and we have a folder called our model. This is our file. So in order to, I don't know, let me say, upload this model to the flash drive and to transfer it to another computer, you'll need both of these files. So that's important. You'll need both of these files. Okay. Now I'm going back here. Going again to the View. And for example, I'm going to the DDL file editor again. And now I again choose Oracle 12c Cloud Database and I choose this Generate. Okay. Finally, I go to the OK. And now, based on our first logical then physical relational model, we've created or generated DDL statements. And these DDL data definition language statements can be used in the production environment to implement real tables, fields, primary keys, foreign keys, unique keys, and everything else. So that's this for today's video. It was just a basic introduction to Oracle SQL Developer Data Modeler. See you next time, and I wish you all a nice and pleasant day.